Welcome back, everyone. In this video, I hacked the Starlink router to power it directly with DC power. Alright, so by now I assume you've seen our previous two videos where I've shown how to flat mount the Starlink dish flat on your rooftop. That, of course, is optional. And then power it with DC, either using the Tycoon PoE injector or the brand new Dishy DC 12-volt PoE injector. But I have some other friends and other travelers who are messaging me saying they don't need something so complex with RJ45 wired Ethernet connections. They just need their phone to get online and surf the Instagrams and TikToks. And so in this video, I'm going to show you several methods that you can power the original Starlink router with DC power. Okay, for these demonstrations, I've reconnected our dish using a coupler back to the original Starlink router. And the first thing we need to do is open these up. Now, these are sealed up without any visible screws or fasteners, in much the way that modern smartphones are glued together with the glass screen on the front. So these are really hard to get open, and I'm not sure how you... Basically what I did was I used this metal spudger tool from a phone repair kit and just lifted it just enough that I could get in the corner with this fine piece of steel wire. This is just stainless steel lock wire, and then I just pulled it through like cutting cheese. So that's a quick and easy way to get in, and it doesn't mar up these plastic edges. So lots of other people prying them open with screwdrivers and knives of all kinds, but because the angle that this is glued in here, it's hard to get the knife around all those corners. Okay, so I am by far the first person to have opened up a Starlink router. There's lots of teardowns and tutorials online, but basically there's two sections in here. There's a main router on the top PCB here with a little digis that comes down to where the connector is. And then the bottom section down here is the 110 or 230 volt for the Europeans. It auto switches and then produces 12 and 48 volts, which is fed through this little 8-pin header here up into the Wi-Fi router section. Now, I've got this powered up right now. Hopefully you'll be able to see the little white LED on the power supply circuit board in there. So I'm going to try and show you several methods of increasing severity that you'll be able to power this from DC. The heatsink and everything is all kind of riveted together with these plastic melted heat stake fasteners. So to get this open involves a little bit more cutting and grinding and so on. And so the first method I'm going to show you, I'm just going to tag on to the top of these pins here. This direction is up, and these 8 pins here are wired earth, ground, 12 volt, the white LED, and then on the second row is 48, 48, ground, and the blue LED. And so first thing I'm going to do here is the 48 volts. I've got a little bit of flux on the wire, and I just tin that up. So now I've trimmed that wire so it's long enough to just reach those 2 pins. Then I'll want to do the same and tin the wires on the, or rather the tips of those terminals. Alright, I'll try and show you guys this while I can barely see it, but just reach around the corner here and just put a little solder on each of those tops of those header pins. And now with both of those pre-tinned, I can come in here and just reheat that solder, and it'll stick to the top of both of those headers. Alright, got the black wire tinned for the ground, and I'm going to do this one on the top row on the second connector in here. And lastly, a red wire for the 12 volts. Now, if you were doing this permanently, you would put some shrink tubing over each of the connections and then restrain it. You can see here I've used a little black zip tie around there, and make sure these wires are well insulated and not going to chafe on any of these aluminum edges. But because this is just temporary and I'm taking it apart, I'm not going to bother with that. Then from there, what I'd probably do is the bottom of the original Starlink router. This gray piece is just a trim piece. It doesn't do anything. So you can use a pry tool like this, pop that out, and then I'd probably come out right here, right next to the Starlink dish cable. Just used a 6mm hole there, a little bit tight, but it'll fit these 3 cables really nice. And they can just all tuck down in there and along this channel here. And then, if you like, the Starlink glass, original glass, should fit on the front there like that. And you've got your ground, 48 volt and 12 volt leads coming out here. Alright, now before you power this up, you of course want to test to make sure you haven't got adjacent pins shorted or anything funny. I'm sure I don't, but I'll show you how to do that. So, safety first. Try and line this up where you can see. And then for added safety so that you don't accidentally touch these bare ends together, I'm going to temporarily use everyone's favorite Wago 221s, but it doesn't need to be temporary either. These are perfectly acceptable for permanent hookups. So now we've got ends covered, and just want to first set your meter to continuity and make sure you have no connection between them or a very high resistance. The only ones that might be connected in my case are the 12 volt and ground because they were adjacent pins. But as you see here, 15 kilo ohms, so that's looking good. Now the next thing we can do is get the original power cord. I don't have the dish connected, only the power here now. Plug that in. And you can see the white LED here. It's powered up. And I will put my probe ground in this. Come here, you. In there. And then we can test with the voltmeter set to volts. Test that on the orange cord we should have 48 volts. In this case, almost 50. And on the 12 volt red, 12.06. So now we are confident these are connected and nothing shorted. Now we can continue to injecting some DC power into this unit. Okay, so we need to send 12 and 48 volts up these wires. Now, in an RV, you might think that you have a 12 volt battery and that should work just fine for the 12 volt part of things. In fact, your battery system in an RV is probably fluctuating wildly between 11 and 14.4, especially if you're charging your house batteries off of the engine alternator. And that's not close enough to 12.0. So for that reason, you need a 12 volt regulator. This is an example here. These are commonly available in many different DC to DC converting voltages. This one is 12 to 24 volts in and 12 volts out. And you'll see here in a bit, it's exactly 12 volts out. This is a little bit big, a little bit overkill for this application. This is another really good option. These are the LM2596 modules, and they'll take, I think, up to 60 volts in, and then you can adjust the voltage with this little set screw here to anything less than its input voltage, and it'll put that out here. So that would be a really good option. And now for the 48 volt side, This is the one I showed in the first Starlink video. This is 12 volts input and 48 volt output, 145 watts. So that would work fine for the 48 volt side. Additionally, the Dishy DC Power Supply has the auxiliary output port on there. I showed this in our last video. This would work also just fine, although if you've got this, you're probably going to use this for power over Ethernet and do it properly that way. But just showing it that it is a viable option. You can take the 48 volts from here and send it up the orange wire. Now, something I didn't mention earlier is the benefit of doing it this way is that you can use the original power cord and plug it into 110 volt AC and still use it in its original configuration, or you can disconnect it and run it from DC. But it is possible to have both connected at the same time, and that would be a very bad idea. So you need to be aware of those risks and have only one or the other connected. Alright, because this is temporary, it's going to be a little bit of a mess of wires, but I'll do my best to show you. From the orange, red, and black wires coming out of the Starlink, the red is 12 volts, and that goes to the output of the 12 volt regulator. The orange goes to the yellow, which is the output of the 48 volt regulator, and the black is connected to both of the grounds on the black outputs. And of course we need to feed 12 volts in on both the 12 and 48 volt power supplies. And so I will do that also here with the Wago connectors. Ground to ground, the other ground to ground, and then positive, and the other positive. So, admittedly, this looks like a bit of a mess. These wires are far too long, but I left them that way for ease of demonstration. You could, of course, take both of these power supplies and hot glue them on the front or on the back or anywhere you want. But for now, I'm just going to leave them on the table, and let's power it up and show you that it works. So to power the two regulators, I'm just going to plug this in off camera here, and you should be able to see the white LED. I powered everything up, and I expected the LED light to come on in the bottom here, but it didn't. But I gave it another minute, and sure enough, Starlink is powered up. Contact. Okay, it's been about 2 minutes since I powered it up. It's really unfortunate the LED light doesn't come on, but I digress. As you can see, connected to our MoFi router, and there is the Starlink. And when I connect to that, we're online. So, aside from all these wires being too long, a little bit of a mess, you can see how I've done it here. That is a clean and viable option that lets you run DC or AC. Alright, so that's that method kind of wrapped up. Like I said, you could stash these somewhere, you know, behind the router, in front of the router, however you want. But that's enough of this one. I'll take this all apart and show you the next method. So this next method is quite a bit more invasive. We need to drill all of these white plastic heat-staked posts, one out in here, and take this all apart. So the easiest way to do that Just a 6mm drill. It'll just pop off just like this. So when you drill them, you should just be able to get the head off, just like that. And then the heatsink lifts out of the way, and now we can more clearly see the back of the Wi-Fi board, and then down here, the original power supply. Gotta get the Wi-Fi board out. There's one more heat stake to drill here. That one worked pretty well, so good example. It's nice and slow, couple turns, and the head will just pop right off. After you have all the rivet heads drilled, there's two little posts down here by the Dishy connector that also need to be clipped off, and then this should lift out of here. Now, it's going to take a little coercion down here because there's two tabs routed into the PCB that force you to lift it squarely. And I imagine this is going to be a little extra difficult for me because I've got some solder. Oh no, not so bad. I expected these pins. Actually, I just ripped the circuit off. Ripped the pins right off the circuit board. So that's going to require some repair. Okay, as you probably saw in that last clip, I had some remnants of solder on these pins after I removed the wires, and then when I went to lift this whole board out, the through-hole header got caught on some of the solder, and it pulled the connector right off the back of the board. And here's my repair. I just needed to scrape a little bit of the solder on either side of the pin and reconnect it. It was the duplicate 48 volt power and the duplicate ground that tore off, which I was able to verify are both redundant. They're both connected to each other. So in fact it would have still worked. But anyway, there you can see the repair. That shouldn't be a expected problem for you because you won't have solder on these pins when you remove yours. Okay, so now looking at the 2x8 header at the top of the power supply, this next method is effectively doing the exact same thing. We're injecting power into these pins just as we did when we soldered on the top. The only difference is we've of course taken out the Wi-Fi board up here, and we're going to solder directly to the board on the power supply. And so to verify which pins are which, this trace right here, you can see with the vias, where it says J2, I've scraped a little bit from the edge there, and that confirms that right here where it says J2, that's the 12 volt, and then over here, this and this, as seen here, is the ground. So this whole area, all the way up over here, this is all ground. And then just right here where it says 8, maybe do this one backwards, which is 8, those are the, this area is the 48 volt part. So all we need to do is just scrape some of this green solder mask away. So to scrape these, I'm going to use an old damaged screwdriver, and I just took some sandpaper and kind of sharpened it up at the edge. And you want a fairly large area because you want lots of surface area, because you need lots of area, first of all, to make the good contact and to have a good secure connection, and secondly, structural connection. This is going to have the strain of whatever wire vibration you're dealing with, and so this needs to have enough area so that you don't just pull the trace off the PCB. So pretty much like this, I'm going to continue and do a better job off camera, where I can really get in there and see what I'm doing. And I'll be right back with you. Okay, I've got her all scraped off, and some alcohol on a definitely don't put it in your ear cleaner. Put a little bit of gel flux or liquid flux on each of these zones. And then I'm going to come in with my beloved TS100 soldering iron and just pre-tin these areas. Just like that. On a nice little globule like that. Make sure you've got really nice heat transfer, and now those are ready to go. Change this up to a little bit different angle, but I assume you guys will follow along. Since the wire is pre-tinned and that pad is pre-tinned, you can just touch off on it like that. It's nice and secure. I'll move this around to the 12 volts. As you can see, I've got the 12 volts connected here, 48 volts in the ground, and of course it's wise to restrain everything, maybe hot glue or silicone this in place, and then the wires all run through the bottom, just as they did before. The benefit of this method is this is probably easier to solder than soldering to the tip of these header pins, but the effect is the same, and of course when the original Wi-Fi router is reinstalled, the header pins still stick through the board as original. And as you can see, I've drilled these plastic posts with a 2mm drill, which will allow you to use a small screw and a washer to retain everything back in its original location. Alright guys, it's been a few weeks since I filmed the first part of this video. As you may have heard in those last clips, we were getting hit with some pretty severe thunderstorms and torrential downpours. But we're back at her now. As you can see, I've drilled and tapped these plastic holes for M3 fasteners, so everything's nice and secure in there now. And for this version of the mod, I'm going to have the glass in there, and then I'll be using the Dishy DC 48 volt power supply, as well as the LM2596 step-down converter. And just to keep everything in place for demonstration purposes, I'll just put a little bit of two-sided tape on the back of these power converters just to hold them in place. And I'll show you now how to hook it up. Okay, as you can see, I've connected our house batteries, 13.2 volts, directly to the inputs of the Dishy DC, as well as the LM2596 power supplies. And as before, it's 13.3 volts on the input. Now the output of Dishy DC, 49.3. And then the output of the 2596, 12.7. That's a little bit high, but it is adjustable. That's the whole point of this device. So we can turn this little set screw on the potentiometer and bring that down to 12.0. So now that we've confirmed 48 volts on the Dishy DC output and 12 volts on the adjustable power supply output, now we can connect our black, orange, and red wires from before. As you can see, I've got the 12 volt positive output going into the red wire, 48 volt positive into the orange, and black is ground. Now both of these power supplies have a common ground. There's a direct connection between the ground's input and output on both power supplies. So I don't need to connect the negative on this one. And now we're ready to power it up. So now scanning for the access point here. These two access points are coming from our MoFi 5500, and there's the Starlink. Connected, and obviously it's showing disconnected because it's disconnected. But at least we can tell that this is all powered up and working, and now we can ensure that our Starlink is plugged in. Alright, as you can see on the bottom of the router, the AC input is not connected, only the dish pigtail here and the DC power wires that run up to our DC power supplies. Now I can connect my little coupler and then plug this whole thing in. And a moment later it comes online. You can see the dish initially shows that it's angled and then it goes back to flat, and the network setting shows our main router and my one device connected to the router. So there you have it, a couple of many possible options to convert your original Starlink router to DC power. I'd like to take a quick break to thank our supporting channel members. It's the support of these fine folks that let us make the videos we want to make and not shill for big VPN and garbage video games. Especially our Elon tier member, Furious George. Thank you very much for your support. He's putting up the pesos once again this month for our Starlink service. We really appreciate that. So anyway, when I set out to make this video, I had intended to show several increasing severity modifications that you could do. Not just with the external power supplies as I've shown here, but I'd hoped to modify it so that we could remove the AC power supply from within the original Starlink router and put the DC power supply inside the original enclosure. Unfortunately, now that I have got in there and I see what I'm up against, I don't think these generic aluminum block power supplies are going to fit inside there. I'm still going to give it a shot here, but I think what's going to be necessary is to have a custom made PCB that's the original size as the original Starlink AC power supply, and then you could just drop that in there. Alternatively, we could take the Wi-Fi board out of the original router enclosure and then 3D print ourselves a new enclosure that holds the Wi-Fi board and our power supply of choice, and probably need to do some heat sinks and stuff, and then we could design the enclosure the way we want it, probably with a nice square 90-degree corners so that we could mount it to a wall, something that would be more suitable for an RV environment. But to pull this off properly, it would need to be designed in such a way that you guys can replicate it as well. So I'm not sure if there's enough demand out there. If you guys are interested in such a thing, let me know down in the doobly-doo, and I'll see what we can put together. For me, I'm going to stick with the original Dishy DC power supply with the PoE injection into our MoFi 5500 router. That gives me much better flexibility as to my network settings and configuration, as well as the Wi-Fi signals are quite a bit stronger than the Starlink router's Wi-Fi. So for me, I'm going to stick with the Dishy DC. As I said, the first batch of the Dishy DC power supplies have sold out, but there will be a new batch ready in the coming weeks, so you can get your pre-order in now. The promo code Everlanders is still valid. That'll give you 10% off your order, so you can go check that out. Link is in the doobly-doo. So that's going to be it for this video. Let me know what you guys thought of this hack. Is it doable? Is it something you're going to try? Would you rather have a 3D printed enclosure with the original Starlink router in there and a power supply? Let me know, because it helps me plan how I'm going to do future videos. Thank you very much for watching. We'll see you next time.